Hi, everyone. My name is Fabiana Clement, and I'm co-founder and chief data officer at Data. Before starting, just a few words about myself. My background is in applied mathematics, and I later have specialized myself in data science and machine learning with a master's degree. And well, numbers have always been my passion, which made data science something that made sense as a professional career. But as in any data scientist, I've also tasted the bittersweetness of AI development. The data is not always available, either because collection or was not that great, or because there are privacy constraints that just make the access super hard. And as many of you probably know, things just don't get easier when data is finally available. The truth is, more than half of my time was fully devoted to a hard and time consuming data preparation process. It might sound like a cliche, but I have to say that in my experience, 80% of the data scientist is spent on tuning the data. This brings me to the topic that I want to cover today: data-centric AI in the era of LLMs, and why data is still the future of AI. Though we are now in the era of foundational models, yes, and we all went crazy, right? We had DALI, we had ChatGPT, everything went nuts. Foundational models are trained on broad data sets of unlabeled data, which make them very special. They are definitely the future of AI, where AI models are not only reusable, but are also flexible, making them applicable to just about any domain or even in the industry. But even when these large models can cost about 10 million or more just to have them trained, each new generation has produced an increased accuracy and their flexibility, which, as you can imagine, is enticing for everyone's imagination. The whole industry potential is just huge. Well, as I mentioned, these models are trained in massive amounts of data. They have shown to be quite handy and quite accurate. LLMs, in particular, they have marked a significant leap in our perception of AI capabilities. LLMs like GPT-3 by OpenAI have taken the market by storm and redefined the landscape from several areas like healthcare, marketing, or even cybersecurity. LLMs are models with incredible capabilities, being able to process and understand context, generate coherent text, and even perform some tasks that go beyond language, such as code generation, right? So everyone from time to time is using GitHub Copilot, right? All these capabilities are only leading to a fast resurface of the AI landscape, not only in terms of trends, but also in what concerns the commercial landscape. Serious competition, for example, in the space of code generation, is just taking a place with, for example, GitHub Copilot and Amazon Code Whisperer. But we all know that these models need a ton of data. So what about that? How will they solve the biggest issue of data quality? One may say that garbage in, garbage out is over, right? So these models are generic, flexible, they can take as many data as we want. So have finally LLMs solved one of the biggest bottlenecks for the adoption of AI? Are we finally safe to say that garbage in, garbage out is no more a truth? Well, not quite. And yes, although we have foundational models like LLMs that are conceptually less sensitive to data that is not so great, the truth is that these models are not always great out of the box either. So, in addition, we can say that these models are generalists. So foundational models still have prevalent issues that we have found previously with other machine learning models, such as they're not yet reliable. Yes, we have shown with typographic tests that foundational models can be very easily tricked. As you can see, we have several examples of that in this slide. They are also not context aware. So they have the lack of common sense in the production of non-ethical results from time to time. And yeah, they are sensitive to bias. An oldie but goldie for sure. But yes, the results returned by foundational models and solutions like LLMs are sometimes discriminatory and stereotyping. Furthermore, the success for AI adoption is just not increasing as one would expect. And why? Why are we not there yet in terms of AI adoption? So, if you haven't yet heard about the data gap before, you should have. So, machine learning models are great for sure, and they have already proven to be valuable in helping businesses and organizations to stay competitive. But they always had a price: the availability of the right data. When considering a solution based on a model, as for example, a simple linear regression, it is easy for us to understand that the cost of the available data was very small. After all, with less than 50 observations, you could probably have a nice estimate. Of course, we know that keeping things in the realm of linear relationships is not realistic at all. Mm, Nothing is linear. Well, but, well, a few years forward, we have the revolution of boosting models, and they have changed our perspective about machine learning and how things can be done. No one really cared anymore about support vector machines or simple neural networks. Tree based models were the thing, and they are still, to be honest. But they do require quite more data when compared to a simple linear regression. Well, in this case, it also returns way better results, but that's not the point. In fact, the performance of XGBoost is directly linked as well to the amount of data that they can receive. So, though these models are not um, that sensitive to the different variables or even to some imbalanced behaviors, they are sensitive, or they can get as good as the amount of data that they receive. But of course, not only. Data access, quality, and quantity have always been one of the biggest bottlenecks for AI adoption. So you can see where I'm going. Deep learning and the revolution of the introduction of deep learning models deepen the gap for the adoption of this type of technology. With LLMs, this gap is just even bigger. Data access, available data is all that matters, right? So definitely the race for better data is just starting. Have you heard before about the scaling laws before? The concept is really simple. So the smarter the data that you serve to your models, the smaller and better your models will be. This is not only good in terms of computational costs, but it also in terms of performance and accuracy of your models developed. Data errors and inconsistencies hamper the process of training and evaluation of the models, leading to a need for bigger volumes of data in order to achieve more accurate results. Did you know that is reported that in real world data sets, a percentage of errors is around or ranges around 77 to 50%? Yes, that's a lot. And when you have half of your data sets wrong, what is the point of just using that data? Well, does it exist a good answer for the issue, the quality of data? Yes, a good data curation and preparation strategy. But we will get there. There are two great papers in this space of the laws of scaling that I definitely recommend you having a look. The Chinchilla paper from DeepMind and an original paper by OpenAI called Scaling Laws for Neural Language Models. But what about differentiation? I just mentioned that these models tend to be generalists. And in an era where we see LLMs, for example, becoming commoditized. We have a lot of open source models now. Not not everything is proprietary anymore. How can we ensure differentiation, right? So they are generalists. There are tons of open source around it. So, as I mentioned before, these models not always, and because they are generalists, they not always work great out of the box. So, what can you do? Wait for a better model? Perhaps someone will come up with something better? Well, that's probably not the best strategy, especially if this is something core for your business. So, the battle for example, access for data ownership or public data that is really relevant have just started. Probably many of you have seen Reddit and even Twitter claiming the ownership of their very human data and asking for them to be paid when that data is used to train models such as GPT-3, GPT-4 from OpenAI. And that just let us know that in order to preserve the magic of foundational models for different domains, private and proprietary data is what makes the difference. And in the end, well, yes, it's all about data, even for the adoption of LLMs in a business context. In fact, in order to improve LLMs outcomes for certain applications, there are different techniques that can be leveraged. From prompting engineer to fine tuning, there are several methods that are focused in improving LLMs with data more fit to the end goal application. Let me give you some examples. When it comes to fine tuning, this is a process of taking a pre trained LLM and further training it on a smaller, specific data set to adapt it for a particular task or to improve its performance. By fine tuning, we are just adjusting the model's weights based on our data, making more tailored to a specific application. So, as we can see, the difference or making LLMs to be less generic is just adapting them to the data that we have. And this is one of the best options that we might have, especially if we don't want to train our own LLM. That's very expensive, right? The other one that is really interesting, it's called Retrieval Augmented Generation, or RAG. This is an approach that integrates the power of retrieval, or, well, as probably many of you know by, is searching into LLM text generation. So it combines a retrieval system like a database, for example, a vector database that fetches relevant document snippets from a large corpus. And from there, the LLM produces answers using the information from those snippets. In essence, RAG helps the model to look up for external information to improve its responses. So another way of using the data, less expensive than the last one, as it does not require training, but still, it's data that is making these models less generalists and more tailored to specific business cases. And that is where it comes data-centric AI, and why I'm saying that the future of LLMs is data, and well, data-centric AI is the answer for these issues. In what we call data-centric AI, or especially for if we consider an engineering background, data prep ops, we can tell that this is the approach to AI development that considers the training data set as the centerpiece of the solution instead of the model. What does this mean compared to a model centric? Is that instead of hyperparameter tune the different parameters of our model, we focus rather on tuning the data, selecting different strategies, for example, for the data preparation, and watching the impact of those strategies on the model that we are developing. This is why data-centric AI is so important. And this is why it is putting a reminder that even though we have LLMs and other foundational models, and they are pretty sophisticated, data itself is still the main element for the development of AI. and it's still the one that can take a model from working to not working. As we move into the foundational models and data in the cloud era, business needs to seek for robustness, reliability, and scale of their data pipelines and systems. Above all, the process of assessing and ensuring the quality of data needs to go beyond the siloed and static approach adopted in many AI projects. Data needs to be profiled, cleaned, enriched, not once, but several times. The approach of doing these validations and, well, profiling, cleaning, enriching only once is what is taking organizations not to scale and stay competitive when it comes to AI. And if they want to leverage all of the available data sources to develop several models, well, there is a need to change in the approach. In the end, we need to consider that the data science lifecycle goes from the problem statement, getting the right data and preparing it, all the way to the model deployment and monitoring. It's an iterative process that needs to be reproducible and scalable. And this is where data focuses. We are making it much easier to access, clean, and prepare the data for data scientists. So instead of focusing on spending time on cleaning and preparing data, these teams can not only start delivering, but also improving existing baselines. So, as we mentioned, even LLMs can benefit a lot from getting the right data. The more accurate and the more clean your data is, the better will be your foundational model, regardless of your choice. And well, proof of that is the latest versions of GPT-4, for example, and GPT-4.5, where the data was the biggest change in terms of how they have trained the model. The data is getting more and better and highly curated in order to get more accurate results from the system. And that's what we know, that in any type of machine learning model, any type of AI system, that can really help organizations to adopt correctly AI. And just as a quick recap, we consider there are different steps that are core to the process of AI and adopting a data-centric AI approach. One of them, the data profiling. We need to consider the data profiling as a data quality standard. This is the foundational step to ensure that your data, or you start your AI project with the right data. In Y Data Fabric, our development platform focused on the data, data profiling is served as a data inventory. So you can have a centralized system to assess all your data assets and understand how the different assets can impact your machine learning project. We also have data preparation, and of course, data preparation with smart synthetic data. We consider that there are several different approaches for data preparation and enhancing the quality of your data, from feature engineering all the way to, for example, data augmentation. In this realm, synthetic data work as a performance enhancer, being able to not only augment data whenever you have lack of it, or even balance in mitigating some biases and imbalanced behaviors, or just getting your data with higher variability for some subpopulations. So synthetic data is definitely one of the key features for the future in the data science development, especially in an era where LLMs are becoming core to the AI landscape. And last but not the least, Fabric also offers operationalization of pipelines at scale. So what does this mean? All the process of AI development needs to be reproducible and versionable. And well, nothing better than making use of something that we already know to be good as pipelines to make it happen as well for the data preparation. So all the steps of data preparation and preparing your data with Fabric can be versioned and monitored throughout time. So you can see the impact of your data preparation in, for example, your model or outcomes that you are developing. Compare and always optimize towards the results that better benefit the business or the applications that we are building. So thank you for your time. I hope you have understood the impact or why data is the unfair advantage in the era of foundational models. And well, let's keep in mind that there are several core aspects for your data preparation and data creation, being data profiling, synthetic data, and of course, operationalization of your data preparation decisions. Join Data Fabric. We have a free trial available at ydata.ai/register. And well, thank you for today's session.